Okay.
Tell me that you miss me. Tell me where you've been. Tell me, did you make your dreams come true in the end? Tell me or just kiss me. Forget the things you said. Even though the saying goes you should forgive, but don't forget. I'm over it, I'm missing the way we used to dance. The way your eyes would light up anytime you saw your friends. I know that you don't miss me. I don't know where you've been. I know you got a new man, is he better than I am? So here we go again. Tell me, tell me, tell me where you go at night when you're feeling all alone. So here we go again. Tell me, oh tell me you just come by and tell me you feel at home. Oh, tell me that you miss me. Tell me where you've been. Tell me about your new boyfriend. Is he better than I am? He probably isn't, I'm not kidding. I just got out the pen. I know you heard, you're probably happy you got out when you didn't. I recall you used to think I'd never make it out of city. Your mother used to ask you why the hell you even with me. I never spoke about my problems, I'd be there for yours instead. I'd rather never fight, I can't go back to my twin bed. So bury me in drama, tell me all the things they did. Never ask about me, baby, I wouldn't tell you if you did. So here we go again. Tell me,
Okay.
tell me where you go at night when you're feeling all alone. So here we go again. Tell me,
We're just getting tea. Then we start in a bit, yeah? In about a minute.
come by and tell me you feel at home. Whoa. I'm terrified, letting go. I'm terrified, leaving home. To let you go, leave my home, the unknown. If you're all alone, I know deserve. Getting my feelings hurt. I don't wanna be here. I don't wanna be near desert. When you're not here by my side, I swear I'm losing my mind. You tell me how to move on. You show me how to be strong. Each second feel way too long without you. You're the only place I belong. Now I don't know where to run. Why does everything feel so wrong without you? No matter what I do, I always seem to make things worse. How come I always get all last when I put you first? I feel always a blessing, but now I know it's a curse. Cause I hear your heart and you but my return. Even after you treated me this way, I still can't make it go away. Cause I felt too hard, but you didn't fall from the start. I don't wanna be here, I don't wanna be near desert. What did I do to deserve? Getting my feelings hurt. I don't wanna be here, I don't wanna be near desert. When you're not here by my side, I swear I'm losing my mind. I don't wanna be conscious no longer. Sipping in any down on my sorrows. I don't even wanna think about tomorrow. I know I probably shouldn't finish the bottle. Fuck. Now I'm just going insane. Henny is taking control of my brain. I'm sitting drunk and say I can't explain. Cause I need to cure all the pain. Yeah, I need to cure all the pain that you cause. I hit a blunt who goes working in parts. There's no escaping me, you feel this loss. Time doesn't end when it's covered in frost. Now I wish that you would never mind. Wish that I could be alright. You're the reason that I don't wanna be here, I don't wanna be near desert. What did I do to deserve? Getting my feelings hurt. I don't wanna be here, I don't wanna be near desert. When you're not here by my side, I swear I'm losing my mind. I could walk 1,000 miles to see you smile. I won't, so take your bet off of me. I'm gonna take my vows tonight. Sometimes I wish I had left to get you off my back. Bad luck, then if we do, then if we don't, so why don't you kiss me inside of love? And till I'm blue in the face, we run until we can't know. I will do whatever it takes to put you back in your place. And don't make no mistake, I'll behave on one condition. Make me whole again, so I can bless you in abundance of sin. Talk to me, my dear, you can kiss me now. We can work this shit out, it's about
Right. Okay. So welcome. Yeah, I hope the music is not too loud. We're gonna do another session this evening. Earlier we had done error handling and something on generics. Yeah. And now, yeah, we're gonna continue. I don't think we finished generics because we only did. I think we only did. We only did method generics. We didn't do struct generics, and yeah, I think that was all we did. All right, so you tell me if the music is loud, or like too loud, and you maybe struggle to hear me or what. Like, I probably let's do like an hour 30 minutes stream. Yeah, well, let's see how it goes anyway. All right, so again, we're doing Rustlings. We're trying to get familiar with the syntax and how the language works. Yeah, so we can use it to write some programs. Yeah, I mean, basically build different kinds of tools. Maybe we do. Yeah, I think I was working on a video processing tool previously. Yeah, I'll continue working on that afterwards. Yeah, so just stick around. Yeah. Right. Okay, so let's go back to error handling. or generics, yeah. So we should go back to. Yeah, as I was saying, we did method generics. Yeah, so now we should be, yeah, we're looking at the std compare module, yeah, and we saw the partial odd and the partial equal traits. We also saw the equal trait, the odd trait, yeah. We basically saw those traits, yeah, and how they're used, yeah. Earlier, that's what a part of what we're looking at. So basically, partial odd allows us to compare, right? So to compare elements of some kind of collection, yeah. So let's see struct definitions. So here we can define structs to use generic type parameters in one or more fields using the angle brackets, like both of them. If the music is disturbing me, I can turn it off, but for now let's just keep going. So this figure defines point as in the generic point struct over generic parameter t. It holds x and y coordinates of any type. Yep. So this is how you use generics in structs. So you have like so first you define the generic parameter, type parameter, and then you use it. Yeah, like so. So it's similar to the one for function definitions. We first declare the type parameter inside the angle brackets just after the name of the struct, and we use the generic type. So yeah, so we've only used one generic type to define point, a generic point struct. The definition says that the point, the point struct over generic type parameter t, yeah, that is a generic over some type t. So the point is the generic over some type t, and the fields x and y are both that same type, whatever that type may be. So basically, if we define point over some generic type t that has values of different types, it won't compile like this, right? So this is an integer and this is a floating point. It won't work. Yeah, if we wanted to define the ones that could hold multiple types, we have to define multiple generic type parameters. Like this, now we define t and u, like so, and now we can use them. Different types. Okay. So we can even use it in enum definitions, yeah, like we did with option or with result. Like this. Yeah, when we recognize situations in our code with multiple structs or enums that differ only in the types of values they hold, we can avoid duplication by using generics instead. Okay. And this is method definition. So we looked at function first. Now we look at structs, we look at enums, and then we look at method definitions. So we can implement methods on structs and enums, like so we have a point struct over generic type t, generic type parameter t, and this is how we would do it. Yeah, so we need to use this in the method. So for that we need to first have an implementation, where we can define the generic type parameter. Okay. And it allows us to use it. Let's see the explanation of this. So we defined a method named x. Yeah, this one here. By the way. Yeah, so we define a method named x on the point generic over type parameter t, that struct that will return a reference to x field of the type. Yeah. So now note that we have to declare the generic type parameter t just after implementation. Yeah. So that we can use the generic type parameter to specify that we are implementing methods on the type. The type point over the generic t. That's how we have to do it. By declaring t as a generic type after implementation, Rust can identify that the type in the angle bracket in point is a generic type rather than a concrete type. How do you mean by? Said we could have chosen a different name for this generic type parameter than the generic type parameter declared in the struct definition. Yeah, so basically this doesn't have to be t. It can be something else. Doesn't matter. So basically, if we write a method within an implementation that declares a generic type, that method will be defined on any instance of the type, no matter what concrete type ends up substituting for the generic type. And we can also specify constraints on generic type parameters when defining methods on the type. We could, for example, implement methods for only point f32 instances rather than on point generic instances with any generic type. Okay. We use the concrete type f32, meaning that we don't declare any types after implementation. Okay. So what is this? We have a struct. We have point struct as a generic over type parameters x1 and y1. Yeah. And then we have a generic implementation. We define the two type parameters again over the generic point type. And then we define a mix-up method here that allows us to use the x1. Okay. Wait, what did he say here? It said generic type parameters in the struct definition aren't always the same as those you use in this in that same struct method signatures. Okay. So here we use the generic types x1 and y1 for point struct, yeah, for the struct itself, yeah, and then x1, okay, which are x1 y1 for the struct here, exactly, and then x2 y2 for the mix-up. Method signature to make the example clearer. Okay, so it just means that it doesn't have to be the same. Method creates a new point instance with the x value from self. Self point is and the y value from the past in. Yeah. So it gives you a point with where the x is from x1, the first generic type parameter, and y, and then y is from the second. Interesting. I mean, so this is an example. We have p1, which is a point, 5, so numeric, or integer and floating point. P2 is a point, string, and char. Yeah, you can do that. And then you do p1 dot mix up p2. So what you'd have here is a new point where x is p1 dot mix up, where x is 5 and y is c. So now we'll have, let's write this one actually. Oh look, we're right about it. I mean, we'll write some generic code in a bit, but let's see. Performance of code using generics. You might be wondering whether there's a runtime cost. I think Rust has what they call zero cost abstraction, which means that it generates the concrete types during compilation and then swaps them. I mean, it uses the actual one. So I think you call that monomorphization. I just even saw that and I recall from before. So here, Rust accomplishes by performing memorization of the code using generics at compile time exactly. So, and this is the process of turning generic code into specific code by filling the concrete types that are used when compiled. In this process, the compiler does the opposite of the steps we use in creating generic function. The compiler looks at all the places where generic code is called and generates code for the concrete types the code is called with. So basically, if we use the option enum, like so, when Rust compiles this code to perform memorization, when it presses the compiler, we read the values that have been used in option generic instances. It identifies two kinds of options. One is an i32, one is an f64. Yeah, and then it will expand the generic definition of option into two definitions specialized to i32 and f64, thereby replacing that with something that looks like this. So you have like something that looks like option i32 and option f64, and this is how it would be. So basically, what this means is that we don't exactly need generic, so we can, I mean, if the cost of, if generics were to be very expensive to wrap your head around, and you can write the code, I mean, of course, we have AI tools that can help us do that right now. You probably don't need that. That's basically what I get here, right? So, I mean, you can say the same for actually writing code in the first place. Since we have those, why not just write in assembly right now? Anyway, that was meant to be a joke, but yeah. But it's just explaining what happens under the hood, yeah. So because Rust compiles generic code into code that specifies the type, so we don't pay any runtime costs for using generics. Makes sense. So Rust generics are efficient at runtime. I think it's Java that has a problem with generics at runtime. Yeah, because of wait, I need to let's confirm this. My keyboard has to wake up. Can you imagine that? Rust uses monophysization to ensure zero cost abstraction at runtime with generics. How does this differ from, say, the JVM languages like Java? What's their issue? Yeah, JVM uses type erasure. Yep. I think they needed to maintain backwards compatibility because they didn't have that before. Yeah. So they didn't reason about generics properly. So I think that was their problem. So monophysization means the compiler generates a separate concrete version. Yes, like that. At runtime, there are no generics, only concrete, fully specified machine code. Yeah, what JVM does instead, it does type erasure. Java compiles generics very differently. The type parameter is erased at compile time and replaced with object or the bound type. So when you do a list of string in your array list and integers near at runtime, both are just list of objects. Yep. Bytecode for both is identical. Difference is no difference at runtime. So the costs, boxing overhead. So in double boolean, they can't extend the object here. So they must be boxed into heap allocated wrapper objects like these. Yeah, store heap pointers, not raw int, extra heap allocation, garbage collector pressure, cache friendly memory layout. Yeah, runtime cost. Remember this thing. Since everything is an object, not a hood, the JVM must insert check cast instructions. Okay, yeah, so we got it anyway. It was just, I just wanted to understand how that differed, right, in another language. Okay, let's go on. Um, I don't know, is this still part of generics? I think this is right. Yeah, I think so. Okay, so shared behavior with traits. Yep. Before we do that, wait. I think let's just recall how to do this. Right. Okay. So, not here. Let's recall how to. So let's say we wanted to do a. So this is generics now. We can have a first function, right? So if we wanted to do functions with generics, then we can do. So let's start with a regular function, yeah. Let's say we have a function that gives us the sum of two numbers, right? Yep. So let's call it sum, and then we say first, and yeah, let's say it's a U32. Second is a U32, right? So it's also going to give us a U32. This is what it would look like, yeah. But let's actually even say that this is like sum U32. Now, the generic one would look like sum, and then we specify we declare a generic type parameter, and then we can say first. Let's say first is also like a reference to this, and second could also be a reference to the generic type parameter we just declared, and then it will give us now a reference to that, yeah. And then that is how it would look. So and so we can say that it's what first plus second, so we want to return. However, we need to specify a trait bound to say that this can only be done for numeric types. Yep. And how do we do that actually? Wait, what? Oh, okay. No, I was supposed to go to. Yep, here. Okay, so I just say Rust numeric type trait. Do we have a trait like that? Is it there, or is they want to add it? This is a crate. Let's see here. Is there a trait for specifying numeric types. Say I wanted a generic function and to use a trait bound. Don't show code. Just answer. Oh, come on, this keyword. There's no single built-in numeric trait in Rust standard library. The std library only gives you fairly granular traits, like add, submol, copy, and you have to combine them yourself with the trait bound, which gets verbose fast. So okay, so the Echo settled on num traits or num traits. I think that's what we saw. It provides exactly what you would expect. Traits like num, primint, float, signed, unsigned, and so on. Interesting. What's this simple? So it said just add traits like add, right? I probably would just use add trait. Let's use something like add trait. Yeah. Okay. Actually, it's already done. We just implementing add with generics. Oh, this is the kind of thing we want to do. So it's on ops. So we have this. Oh yeah. Cashier type output. Why is that necessary to do that one? Wait. So again, the trait add has a function. Why can't I just hold on? Let's see. So why can't I say this just, or maybe yep, maybe I say okay, so this thing get added. I have to add it. Okay. Missing the lifetime specifier. Oopsie. Now we get into lifetimes, yeah? Yeah, we don't need this one first of all. But this now, yeah, because we are, so for us to avoid using lifetimes, we can just do this. I mean, for now, we don't want to do anything about lifetimes, right? So, the expected type parameter, yes. I'll consider restricting this bound. Is that not what we've done here? Oh, like restricting it further, it said. Further restricting this bound by saying output. Oh, that's true because it returns output, right? Like with. Hmm. Um. I think I don't get it. So it says it's an associated. This is required associated type. Oh, so this is the type that gets returned, the resulting type after applying that, and then this is how this was used here. Output equals t, I guess. So we restrict that by doing this here. Okay, so can you do that here? Yeah, you can actually. Okay, then yeah. I think it was like this. Mm-hmm. So what else now? What's that? Oh, 3 and 5. It should not be plus. Yeah, we're trying to play around with generic implementation here. Okay. Okay. So we can do this one. In fact, we can do I think we can we do this? Mm-hmm. Probably. I mean, I don't recall how we did this one here, but I don't know. Let's see. Can you do this? No. Are you able to do this without any parameters? Oh no. Oh no, maybe. Perhaps. Like, no. No. I mean, how do you... I don't recall how you do this again. Okay, so let's see the print line macro. again. Yeah, I just need to have arguments. Yeah, but yeah, but the argument. Oh wait. Okay. This is. Oh yeah, we don't use a result. No, none. It's not needed. Right. So can I, in the same way, also say now pretty print this for me? No. What is missing from here? If you intend to pretty print, we should do what? Suggesting that for us. If you intend to pretty print, you can escape it. What? Interesting. So if you escape this, that's what you mean. You know what? It's easier like this. For the print line macro, see, I wanted to do print line result and pretty print a value supplied as an argument. Problem was the colon. Yeah, how was that gonna work? Okay. Okay. That's what I wanted to do. Okay, so this is just a simple, simple generic function that we've written here, and we're able to use it with different parameter types. Okay, and we can do it with struct. So we can say we can have a pizza or what do we call this struct actually? Let's call the struct I'm just thinking of something for a generic struct that takes multiple things. Yeah. So yep, let's call it a pizza struct. It's a pizza. I mean, it's a generic struct over type parameter t. I'll just say topping. Yeah. Which is the generic type. Yeah. Yeah, that's pretty much it. What else? Size. Again, how do you do? Yeah, I think it's like so, right? Interesting that I don't have. That's very interesting. Small. Large. Okay. Okay, this pizza size is never used. Also, he doesn't want us to do it like so. So he wants us to use like this. Large, like this. Should have upper name. Oh. I guess this is what it wants. Okay, that's correct. Pizza is never used, so a pizza size is never used. That's okay. So yeah, we just defined a struct here, and let's say we wanted to have a generic implementation for creating a new pizza. We would have to do this, defining the type again, define the type, and say that, I mean, define a type parameter. I can even call it anything. It doesn't have to be the same as the type parameter for pizza, because this is different now. And then I'm gonna say it's over the generic struct with the parameter type, with that parameter. Oh wait, hold on. Yeah, actually this one has to be that. Yep. And yep. And now we can implement a method. Yep. Let's call this new. Why did I even call this Q? Q is probably not very much used, right? Remember, this is a method, right? So you have to say self, right? Can we just do that? So we know the kind of pizza that we give you based on the time of day. Mm-hmm. And our restaurant serves different kinds of pizzas depending on time of day. I mean, different pizza with different toppings. Yeah, maybe also the size actually. Um, sorry. Yep. And then we give you you can say self, yeah. Yep. Why not? So let's say that by default we are going to give you a let's just say that what toppings would we give you here actually? Let's say we give you tonefish. Is that a topping, by the way? I have no idea, but whatever. And we give you a large size. What is wrong? So, first use of you. This is the first use. This is the declaration. So here, wait. He says, oh yeah, that's true. We probably don't need to declare it like so anymore because this is as a method. Yep. So it says here mismatched. Mismatched types expected type parameter you found reference to static string. Yeah, this is not a type. Why not? Struct string. Why is string not a type? Can I say I can do that, right? It's not a trait. Okay. Why can't I really use string here actually? You know what? Let's just say we declared just gonna call it topping. Yes, that wasn't a problem. Um. What is the issue here? Expected type parameter found an actual. Is that it? We're trying to create a pizza that is is a passing a concrete type where the compiler expects a generic. So it's expecting a generic here. Ah, wait. So we're saying that, yeah, this is a generic. True. So what topping? But let's look at the example again. Actually, not here. Let's go see the examples and see what, or maybe like, oh no. We have something like this. This is what we did here. We did that too, right? Yeah, we did that. And then this is our method. Look. I see. I think it's expecting a different thing, right? Oh no. But hold on. I thought they said this could be different. Look, it said. So look, like this is something similar to what we have. Something like this is what we have actually. So yeah, it's like what we have. Okay. This is the same here. Is the issue that we have a different one here? So he's expecting something different, maybe? Can we make this instead? Does it change anything? No, it doesn't. So yeah, well, we're correct to say that. Um, okay. Mismatch at expected type parameter u. Yeah, this is not in any way generic actually. So what can we do here? Maybe maybe I say sorry. Maybe so what is the pizza itself is wait. I'll show you what this one looks like. Don't tell me too much about it. I just want to know why I get this. What is it, by the way? Yeah, mismatch types. I want to know why this. Oh, come on. Like the compiler has said, struct holds u in the stopping field. The color decides what u is, but then you're hard coding this. Color might have chosen. Okay. Okay. So it says that we are hard coding this here. Oh wait. So what do you mean? But isn't that what I just did? Here, type is inferred a string from the topping. Oh, come on. Fruit. But I did that, right? Yeah. I did that. Mismatch type, expected type parameter u. Expected. From the new function, not the construction, okay? So when you directly construct like above, Rust infers the type from what you provide. Everything is fine. But inside, u is a promise to the caller. The function must work for any u. So you can't hardcode a string. That's a contradiction. So if we want you to always produce pizza, then we have to drop it. But we don't want to drop it. Now you're implementing a concrete rather than the generic, okay? So the problem is, this is fine. Our issue is, okay. Okay. I think it's this is fine. This will give us a pizza that has the topping as fruit. Yeah, that's how it will look. Okay, expected pizza u, which is the type that we want to return. And this is giving us pizza topping string. Yeah. So actually, so this topping can actually be just a string. We don't need that there. Yeah. Sorry. This can be t. Yes. We don't need this. It's not necessary. And this can just be like so. But this is now yeah, so it's pizza string, but we want this to be a generic. So that's what we need to do. So I think we're closer to it now. So how do we get this one? Because we really need topping to be, so topping can be a string, or it can be what other thing can it be actually? Or it can be okay, actually this is where I wanted it to be an enum. Is I want it to be an enum. But as you make it a generic enum, I think you want that topping can be. I guess this pizza example is not the clearest example of it, but I just want to at least get to this one. So let's first think of an example of another so we have yeah. Okay, yeah, I think we're onto it when we're saying fruit. Yeah, custom type and plain, yes. Okay, I think that's a good idea. And that was what we were doing earlier, actually. I think it was still saying, yeah, okay. We fruit off. What's the difference in that? Oh no. I think it's meant to be like this, yeah. Okay. So then if we say this is this is actually pizza U in this case, like what we had before. So we're back where we started. And what is the issue now? So you have mismatch types, expected struct pizza U, found struct pizza this. I wanted to copy this. Well, it doesn't match the type. It doesn't match the type. It needs pizza U. Well, we tried pizza string, that didn't cut it. You might want topping string for a name topping, yes. But now the method gives expected pizza you got it's about got what pizza topping it said, right? Pizza topping string. Bad return type, bad, yeah. Because our struct is like this. Pizza topping. Pizza, you mean the topping field expects. Aha. So the fix implement on the concrete type. No. Why do I need multiple implementations? It can't be generic at all. Okay. I think we're just complicating it all along. So you're saying we should just stick to string. That's not the example I want to do with generics. So your point is that this should be string. Is that what you were suggesting? Or that we don't need generic there? So your point. Because it's oh yeah, because it was, but this is still going to be, oh yeah, makes sense. This is still going to be pizza T because it's a topping. Okay, I think we reasoned about it wrong. Okay. Then why is this not still fine? Expected struct pizza u now found pizza topping. We're back to the same issue. Not regular. Then pizza holds a topping and you can match. You want us to change that to a concrete type. Okay. So actually, this was not a very good example or use case for generics. Yeah, I was just looking for an example for us to play around with the concepts that we learned. Yeah, but we don't need generic at all here because we can just have topping like this. I have pizza. Well, why does this now need to be generic here? Because we can just simply say it's a topping. Yep. You know what? Yeah. So in this case, I mean, pizza doesn't need to be generic then. Yep. So we don't need that. And then this is also not needed. So yeah, this is not the good use case for it. Okay. Yeah, it's not a good use case for it. So yeah, we will find some use case for generic, but I mean for implementation. But this was not a good use case. What we wanted to do was to say that we can do a match on time of day. This was the idea I had earlier. Yeah. Then no. Why does it look like it's not right? What's this one? Oh yeah. This is the pizza one. This is the one for here. This is the one for implementation. Yeah, this should have been okay. Well, I don't want to. Oh, you have to return something, right? I'm not sure why. I was trying to have pizza topping. This, yeah, this is I don't get why this is not properly formatted. Whatever. Okay, then anyway, so yeah, we match on time of day. Oh, yep. I know why now, actually. So based on the time of day, I think we can actually match on literal values, right? So I think we can do it like how do we bind a value here now? Is it like what is, wait, hold on, let's see how, let's check how do you bind. I think it was in, what chapter is that of this book? This is match. Matching on the norms, right? What's that now? Oh yeah, I think it's something like this we want to do. Oh, so we can just match on the literal itself directly. Yep. So we can match on can we do this? Up to equal to then we want to do this. Okay. Oh, missing size, yeah. Okay, so missing a semicolon here. Okay. Yeah, so we can do this. The syntax is correct. So we can go from in time of days before 12 o'clock or like up to 12 o'clock we're gonna do this one. That's fine. Yeah, otherwise yeah, otherwise we want to do plain pizza for everyone. We're gonna give them a small pizza. Yeah. So what is my type expected pizza? Oh yeah, we haven't returned this, so we don't need to do a return. We don't need to declare this. We can just do this, right? Yep. Then we remove this. Yep. Yeah, we don't need this anymore, right? Yeah. Okay. So that's the function is never used. That's fine. Yeah, so anyway, this is not exactly generics at this point because I think we had a plan, but yeah, I guess we're just playing around with the with this here. Yeah, we'll continue with this part. Wait, hold on. Okay, I think it's a new, so well, if we wanted to do that one, we would just do new pizza. Specify the time of day as 10 o'clock, and we see what pizza we get. We can then do a print line and say we got a. By the way, we cannot print pizza because I mean we need to implement debug trait on it, but yeah, I think we got a. So we can do it like this. Pizza. And we use the pretty print for it. Yeah, it doesn't implement debug traits. I know, so let's go implement debug trait on it. So that will be derive debug. We should get the same thing for pizza size, right? Yep, exactly. So we should do the same thing for here also. Okay. So I guess that should be okay. Yeah, we got a large pizza. What if we got there at 1300 hours? Yeah, we get a small pizza. Yeah, it's okay. Yeah, so anyway, we will continue with generics. We have yeah, this is mostly about error handling. I think there's more on generics actually in this one, so maybe we can actually even take care of error handling exercises. Anyway, we'll do that tomorrow, yeah, or next time. All right, then have a good evening. Yeah, we'll continue next time. Bye.